Welcome to another short repair video. In this video we're going to look at the Epson EB-410we's, and I've had these in before. I have another video on it. I'll put a link in for that. And the biggest problem I'm finding with them is when you plug them in. I'll show you. I'm just going to have to hold the lamp cover in. I'm going to power it up. My temperature light flashes and the unit will eventually shut down, and this is normally associated with the cooling fans, and I'm just going to show a way how to figure out which fan is giving the problem. You have only a brief period to do this because you have to check the fans at switch on, because it will shut down and go into protection mode then, so the voltages will disappear. But you have enough time to at least check one or two of your fans and go around. I think there's about 4 fans in this altogether. I'll just plug it out. I have it undone already. The screw is on the bottom. I just got to be careful with the cable below. The cable here. Just going to lay that aside. See, can we get it in? Just going to clip it out for now. That's that. Now I'm also going to put something in here too. There's a switch down here for the lamp cover. Just going to put that in there just to close them contacts. And I'm going to use my scope and connect one lead to ground. Find a suitable ground for it. And we have, they're all 3 wired connectors. There's one fan, there's 2, 3, 4, 4 and 5 fans I think there's in it. 1 second. 1, 2, 3, 4, 5. 5 fans in total. What I'm going to do now is plug it in and power it up. And I have to get ready with my scope. The black lead on this is ground. The yellow lead is the signal returned back to the microprocessor that tells you the fan is up and working. I'm just going to show you that first. You see now it's at about 2.5 volts. I got 1 square is 1.5 volt. 2.5 volts. I'm going to put on the 1 volts per square per division, so that's about 1.5 volts. So I'm just going to power it up, see what we'll be able to get it in. See the way it goes down to 0 volts on that one, while maintaining our voltage there. There's our supply voltage. About 6 volts supply to that. Now we know it's in the default mode now at the moment. We know that fan there is okay because that's going correctly. We have our supply, we have our ground. We'll just put this on the ground as well. And I'll show you the ground, which is 0 volts. 0 volts then on the signal, and there's about 6 volts then on the supply of that one. Now I'm going to go over here. There's one over here working as well, and I'm sure it's this one here. Yes, it's blowing out there. Now there's higher voltage going to this one. There's 12 volts going to this one, but the signal return is still at 0. And if you stop that motor, it will the voltage will increase. And there's my ground. And let's go over here to the ones I think are faulty, which is one of these two. I think this saves a lot of time. You know, you could strip down the whole optical engine to get at these, and you'd be at the wrong one. Alright, I'm going to have to plug it out again because well, it shut down itself there. Plug it in. We know we have our 0. Now we have no supply on that now. I'm measuring the supply now. Power up. That's about 4 volts. Now I'll do that again. Maybe I'll go at 1 volt peak to peak, might be better for that. We'll see it. Okay. Power up. Okay, and here's my signal now. It's at ground, it's at 0 volts now. It'll go into protection mode now any minute, and it increases. So we know that fan was turning. Now we have another fan here right beside it. I'm going to do the same thing again. I'm on the supply of it now. There's a supply. Now I'm going under ground. Now see, this one here never goes down. It stays up. It stays at that 3 volts. So we must have a problem with that fan there. And that fan is located beneath the optical engine. I have a link to that video. Here is a brief description of that fan circuit that I was talking about. We have our fan motor and we have a MICOM normally, and what happens is when the unit comes out of standby, we'd have a remote control would take them out of standby. That should, after a set period of time, send either 5 volts or around 7 volts onto the plus pin of the fan motor. There's 5 of them motors there altogether, and I think there's only one of them I've seen around 7 volts on, the larger of the 5 motors. And there should be a ground. And all you have is a connector with 3 wires on each of them. That's it. 3 wires. One is plus, the other is the return, and this here is 0 volts, which is the ground, G and D. What I'd done was put my scope or my multimeter on the connector that goes for the V plus, the B plus to the motor, and I took it out of standby. That should rise to either 5 or 7 volts. When the motor turns, this here will go from around 3 volts down to 0 volts. So it tells the MICOM that it is turning. It doesn't care how fast it is. Some people there are looking for pulses on that there, because that's the way normally a microprocessor works. It looks for a pulse to see how fast the motor is going. If it sees no pulses, it knows it's not working, but it doesn't have to know how fast the motor is going. All it wants to know is if it's working or it's not working. That's all that is. So when that changes to 0 volts, it knows that that's working. But if it doesn't change to 0 volts, it's telling the MICOM that the motor is not turning. What it does then is it shuts down the supply to the fan motor. So you'll see this supply voltage disappearing after a set period. At the same time, the temperature warning light will probably be flashing on the top of the unit. Make sure you also check for your ground. Make sure there's 0 volts on the ground pin of the connector. There's only 3 pins. Every motor would have a different layout, so it's no good me saying the middle one is the signal back to the MICOM or it's the supply, because there's only 3 pins. One should be have voltage there all the time, and the other 2 should be 0 volts at standby. and then what will happen then is the plus voltage will appear when it's telling the motor to turn. We have our unit disassembled, and this is the fan system that I'm talking about. This here is the one that was shown that there was no output from. And move that. I've been in here already before I've started shooting this bit of film, and this here is supposed to move very freely. I don't know if the camera is picking it up or not. Let me just get a closer shot of that. Okay, that's as close as I'm going to go. These blades are supposed to turn freely. While they are turning, they should, if you notice that there, it's sticking. And I'm just going to put a bit of oil in that and see what happens. Here's another shot of the fan from the other side with the cover removed. And you see, it doesn't rotate freely. Now this will just pull out. And if you can see on that, I don't know if you can get it or not. You just see. I'm going to pick it up. That there's a lot of dried up grease on that shaft. Now I found by cleaning up that it will get it going temporarily for you. It'll give you a couple of months, but it will actually seize up again on you. But I'm going to just give you this a temporary clean up, and I'll show you how free it should rotate. I've just cleaned up the beard and got rid of all the dry grease, lubricated a bit, and now this is the way it should at least rotate. It takes very little. If you notice it there, it does continue to turn. It does have that little stop there like that. It does stop at points, but before it wasn't rotating at all, really. You know, it would stop everywhere. No matter where you put it, it would come to a stop. I hope that tip with the checking the outputs of the fan helps you. You don't need a scope to do it. A digital multimeter should be able to do that for you. Just check the power, make sure you got the power, make sure you got ground on the 3 connectors going to each fan. There's 5 fans. When it goes in the default mode, you're going to have to power it down and power back up again, take it out of standby to be able to test those voltages, because it does shut down, so it's not going to be a correct voltage check. The motor has to be commanded on, which means it has to have its 12 volts or its supply, whatever its supply, because you've got different size motors in this, different supply voltages on each motor. They're not all the same. But as long as you've got a supply going to the positive end of the motor and a ground, it should turn. And when it does turn, that return line back to the microprocessor should go down to 0 volts. If it stays up, it means that the motor is not turning. If the motor is not turning, if it stays up, all you have to really do make sure it has its supplies and grounds, and really there's nothing else, only the wire and the connectors in between that and the fan motor itself. It's just a handy way of checking which motor is faulty, because that temperature light switch, that temperature light flashing could mean any fan stopped, and you don't know which one. At least that way you can trace it to the actual one, and you can dig your way down to that particular fan. You might have a fan that's easier to get to. You don't want to be taking out the optical engine as you do for this, if it was one of the other fans that was not turning. Hope that helps you out there. Thanks for watching.